So I'll be sharing my screen. I'll be sharing my screen now. Let's see. I've shared the material for this class already. So if you're on the group chat, you should have seen that. So today we're going to be looking at data preprocessing with Sklearn, basically, right? So we're going to be looking at data preprocessing. So last class, the previous classes, right? So far, when we started machine learning, since when we started machine learning, we've looked at several stuff. We've looked at linear regression. We introduced machine learning initially. We then looked at linear regression and then moved to logistic regression. And then we actually looked at a lot of concepts, like a general conceptual overview of machine learning and some terminologies and all of that. So while we're looking at linear regression, logistic regression, we're introducing some things that don't necessarily specific to those algorithms, but like they span across machine learning generally. So we also looked at Sklearn, which is a library we use for machine learning. One of the libraries, right, we use for machine learning, and that's what we're going. That's the only library we'll be using for this program. Just give you a kind of a good introduction. So we've looked at how to build a logistic regression model using Sklearn, how to import our data set, how to use custom data set basically. All right. So I can't really say every single thing, but we've actually done a little when it comes to machine learning. So today we'll just pick up from there. We're going to look at data preprocessing with Sklearn. Right. So please let me know if everyone can hear me clearly. If there's a need to increase my voice or decrease my voice, or increase my speed, reduce it. I just need feedback so I will know how to continue. All right, great. Okay, so today we'll look at data preprocessing today with Sklearn. All right. Create this first. All right. So by now we all know what Sklearn is. It's nothing new to us again. We're going to just see how we can preprocess our data using Sklearn and all of that. Remember in the last class we used already made data set from Sklearn, so there was no need to actually work on our data set. Right, the aim of that last class was to just show you how we can build models basically. The focus was mostly on using Sklearn and other functionalities like preprocessing and all of that. But today's class, our focus will be more on learning how to preprocess our data. So I'm going to be apologizing now because we might overshoot a little in today's class. Right, we might overshoot, let's say, by 30 minutes or so. So for those that might have some things already scheduled by 6 p.m., I'm so sorry. I'll try as much as I can to make it not so much, but we might overshoot a little. And of course, and obviously, the recording will be made available, so you can always go over the recording. All right, if you're unable to stay before the end or by the end of the class. All right, so we're going to look at some few things. I will just recap basically on Sklearn, and then we move on to doing what we need to do. So yeah. So I've introduced us to Sklearn already, right? So you already know what Sklearn is. You know that Sklearn is a free, you can call it Sklearn or you can call it what Scikit-learn, either of the two, that's fine. Sklearn is a free and beginner friendly Python library, right? So anybody that wants to start machine learning, right, it's essential that you start with Sklearn. And there's something that you actually appreciate this foundation, right? When you're advancing a lot. Like, if I know not everybody here wants to advance like deep into ML and all of that, we probably just need the knowledge for some other things. But for those of us that might want to like focus our career on machine learning, AI engineer, data scientist, and all of that, you appreciate these foundations, right? Because some people that are going into machine learning these days, especially people that are starting now, you notice some trend. For those of us that started previously, we didn't have a lot of like things happening in AI, in the AI field, right? And those times we were still looking at traditional ML algorithms, SGBoost, and all of that. But now everybody's talking about LLM, this, that. Like, no, there's not much focus on all these other algorithms, and these other algorithms are usually the base for this bigger LLM stuff, right? Logistic regression now, it might not necessarily be pronounced, but there's some things that that are being done in the deep learning field, the AI, the bigger AI field, that uses a lot of the concept that we've looked at. It uses logistic regression, uses sigmoid function. You get to learn about what we call activation functions in neural networks, right? These activation functions, an example is sigmoid function. So if you don't understand some of these things, these basics, it will be difficult for you to kind of get comfortable learning the more advanced one, all right? So it's essential that you kind of have a very good and decent understanding of these things, especially in this case, Scikit-learn, right? And this foundational knowledge. And I really wish there was more. Like we had, like, obviously, I think time is the greatest resource we have. So we probably not have a whole lot of that, but there are a lot of other things that we can actually talk about in ML, right? So I would advise you, as I've always been doing, to not limit yourself to only what we've been doing here, right? You can just like try to understand some other things, try to like read up, try to like check out other stuff that we've not really like talked about here, focused on in this course. All right, let's just move ahead. So I'm a kind of person that when I teach, sometimes I might be in full teaching mode. We'll just be doing the technical stuff and focus. But sometimes I like to just dabble into like some practical stuff, helping you understand how these things are being used when it comes to real life scenarios and all of that. So yeah, so let's just move on for time's sake. So we've looked at Sklearn already. All right, we've looked at what it is. We know that it is used for several tasks, right? And it has some algorithms as well, like powerful algorithms that we can use to build ML models. So we also know that we can perform some tasks like classification, regression, right? So this classification and regression, that supervised machine learning. All right, so we already know what they are. I don't need to start explaining it to you again. If you don't know what these things are by this time, I don't know. Honestly, that means you just joined the class today. So we also have clustering. Okay, let me just assess our knowledge. Well, under what type of machine learning do we have clustering? Under what type of machine learning do we have clustering? So remember I told us that we have different kinds of machine learning and all of that. So under what type exactly do we have clustering? All right, fine. That's great. So it's under unsupervised ML, right? So what we're actually looking at so far here is supervised machine learning, right? So we would not be looking at unsupervised and all of that. But just now, clustering is another technique in ML that we can use. So Sklearn also provides you with that functionality. It gives you the access to these kinds of algorithms and techniques, right? So we also looked at the key features. We looked at some things that Sklearn can do. So Sklearn is easy to use, right? From what we saw last week, you can see that the implementation is not so hard, all right? So like the whole explanation on fitting your model, the whole explanation on like training your model, all those examples I gave us, like try to relate it with teaching your a child how to recognize, and all those examples, like everything was wrapped up inside a method, a single method in Sklearn. So when we looked at linear regression and logistic regression specifically, and we wanted to train our data or train a model, right? What was the method we used, right? Like there was a particular method we used, right, that helped us to train the particular model we want to train. All right. So what's the method called, or what's the method name? I just want that interaction, and I'm just using this to also kind of assess where we are currently. So I'm sure that yes, we've been following so far. Let me repeat myself again. What's the method we use to train our model, basically? Like, what method do we use in training our model, a model? So there's a particular method. Thank you, Oluwa Wemimo. It is called fit. It's the fit method, right? Fit method. So all those long talk I was talking, everything was inside what that fit. That simple .fit method is what you use to train your model using your data. Okay, so when you do .fit, you pass in parameters, and those parameters are what your data set, your training data set basically. And under the hood, you don't see what's going on. Everything happens, right? And then you get an output that, yes, your model has been successfully trained. You can now use it to make predictions. Very, very easy, right? So that's one of the key features of Sklearn. Very easy to use. So that's why I kind of dabbled into that. So we also have pre-processing power. And this is what we're going to be looking at today. Sklearn also provides us with pre-processing power. And so we looked at how to perform EDA in pandas, right? We can also perform data cleaning in pandas too. Sklearn also provides us some functionality to perform data cleaning, but I won't necessarily say Sklearn is better than pandas in performing cleaning, but it gives us some functionality, some things, right? Some tools that we can use to pre-process our data. So pre-processing is different from cleaning. All right, I hope you understand that. Don't worry, we're still going to like explain what that means. That is basically what we are going to be talking about the whole class. So we also have model selection and evaluation. So Sklearn provides us with different models, right? We have different algorithms that we can select from to create our model. So Sklearn gave us those options. It also helps us with evaluating our model. And so Sklearn is a starting point. That's the summary of this whole thing. Sklearn is a good starting point for beginners. There are a lot of ML tools that we can use. There are actually some ML tools that are used to evaluate your model. Like their aim basically, or the goal of those libraries, are to just evaluate your model. But Sklearn can do all of these things, and it just helps you to kind of have an end-to-end kind of idea on how to approach machine learning. So that's why we're starting with it. So what we have here next is the basic workflow. We've looked at this already, so I'm just kind of going through the summary of what Sklearn is, and then we move on to preprocessing. So the basic workflow that we've seen so far is that we import our libraries. So if whatever libraries we want to use, we import them first, okay, and then we load our data. Then we pre-process our data. So this part is actually, you can see in the bracket here, is optional, as we had in the last class. So in the assignment and in the last class, there was no pre-processing. Like we didn't do any pre-processing, right? Because our data is already okay. So the reason why we pre-process our data is because we want our data to be in a format that our algorithm can take in, right? So there's something I said, and I think I mentioned it, that your algorithm or your computer don't understand letters. They don't understand anything that is not number. They don't understand it. Okay, so anything that is not number, they can't understand. So you have to pre-process your data to be in a format that they can understand. So that is where pre-processing comes in. But if your data is already well formatted, if it is in the right format, you probably not need to do any pre-processing, right? So that is why we have this particular method or this particular step as optional. All right. So the next thing we have here is splitting our data. So splitting our data is very essential as well. The reason why we see it as optional here is because you can actually just use the entire data to train your data set and have your model. That is if you trust that the model you are building is good enough, and will be performing well, that has good metrics and all of that. But if you feel like you need to actually evaluate your model to understand its performance, then there's always a need to split your data. So I always advise you 10 out of 10 times to always split your data so you can use the test set for evaluation. All right. So the next thing we have here is choosing and selecting our model. And the thing is, before you even start the whole thing, you should already have the model that you want to use in mind. Okay, what model do I want to use? But sometimes you don't even need to restrict yourself to a single model. You can use several algorithms, right? You can use several algorithms to build your model and then test those the performance of those different models, and then select the one that is performing best. Right, so after that, then evaluate your model performance, and you can now start, if it's good enough, you can now start using it to make predictions, right? Which basically means deploying your model, right? So that is it for the basic workflow. Now we're going to move on. We're going to move on from that to what we have for today. So in Sklearn, we have some modules. Remember in the last class, I told us that when we want to work in Sklearn, we import those things that we need. Like, we don't import the entirety of Sklearn. We import stuff from different modules. So we have a lot of modules in Sklearn. We have preprocessing module, as we have here. You can see on the screen. We have model selection module. We have metrics module. We have dataset module, which we've looked at. We have pipeline. We have decomposition. We have linear model, which is for our linear regression, logistic regression, and some other linear models. We have SVM, which is for support vector machine, which is an algorithm as well. We have tree, which is for the tree algorithms, like our decision tree and all of that. We have our ensemble module, which is for ensemble models like our random forest and all of that. So these are the common modules we are going to be working with. There are a whole lot of them, actually. There are a whole lot of them. You can actually just look that up on Sklearn documentation. So, but these are the most common ones that you're going to be coming across. I sent something on the group chat today. I sent a cheat sheet. I don't know how many of us saw it, but I sent a cheat sheet, and it's going to be very helpful. So I've sent several cheat sheets from pandas to matplotlib to numpy, now Sklearn. So if you actually just look at those cheat sheets, you see at a glance the very common feature functions and methods that you'd be using, right? So it just gives you a very good view of the tool you are going to be using. So you probably see all of these things that I'm mentioning there as well. So you can just like have this at the back of your mind. You're going to be using a lot of these modules as we proceed. So now let's go to the class itself. I wanted to actually just go over each of this module and show us some stuff, but I'm looking at time and I don't know if time is going to allow us to do that. So, but you can just check it out yourself. You can see from Sklearn import preprocessing, and you're going to, let me even just see if I can just do for one. I don't really like surface teaching. I like going in there so you get the idea. So let's say you want to like access a module, right? You want to know what a module does, preprocessing. So this preprocessing basically is what we're going to be using in today's class. So we're going to be using, there are a lot of methods and functionalities in this particular module that we'll be using to preprocess our data. Okay, so it's essential that you understand what this preprocessing does. So obviously, if you just do your Shift and Tab, you're going to see the summary. You can see this is a module, right? Type module, and it's a module, an Sklearn module. Okay, and this is what it does. It involves, the module includes scaling, centering, normalization, and so these are some preprocessing stuff that you do with the module. So if I want to check the different attributes and methods, I'll just use my normal dir stuff that we've always been using. So I can come here and just preprocessing. So you can see that some of the functionalities in our in this particular module. So these are the things, the few methods that we can access from this module. So it's not really much, but yeah, just to give you an idea. If you check, let's see, we have model selection. All right, so let's see model selection. Model selection. So it is in this model selection we have our train test split. So if I run this and I come here, I just copy this here. You'll see that it has some other things as well, right? Where's you can see our train test split here, okay, and some other things. So this is just so these are just some of the modules that we have. You can just look them up and just look at the different functions and see if it's something that might be useful. Okay, so let's just move on. As we proceed, we're going to be like interacting with some of them. So data preprocessing. Can everyone still hear me before I proceed? Can everyone hear me? So I hope everyone is following so far. I just want to be sure. All right. Okay, so now today we are looking at, right. So data preprocessing refers basically to a set of transformations and cleaning steps. So data preprocessing comprises cleaning and transformation. So you can actually do some cleaning, right? And it's still under data preprocessing. So everything that involves processing your data from the original form to a machine learning suitable form, all those techniques, they are data preprocessing techniques, right? So the data preprocessing involves all of those steps, from converting your data to a machine learning ready data, or a machine learning ready format. All right. So the goal is to make your data suitable for modeling. So your algorithms can learn effectively. As I said, computers don't see they don't understand letters. They only understand numbers. All right, they only understand numbers. So we need to ensure that what we are giving them is an appropriate format, right? So that is basically what data processing is. So now we're going to learn some of the things, some of the concepts and some of the functionalities, some of the techniques and methods and all of those things that are involved in data preprocessing, right? This is not an exhaustive list. There are a whole lot of other preprocessing techniques that we have out there, but these ones are the most common one. So, but before we go to those techniques, we are going to look at two methods. I'm going to explain those methods to you. We're going to look at two methods. So the first one here is fit, followed by transform, right? So I need you to just stamp these two methods at the back of your head. We have fit and we have transform. So these two methods, they are very, 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 very important methods. Very important methods in Sklearn, right? Even in some other libraries, you would see this fit and fit method as well. So these two methods, they are key in every data preprocessing step. Every data preprocessing technique, or let's just say most data preprocessing technique, use these methods, right? They use either fit or they use transform, or they use a combination of both. So I'm going to explain what this method means, and yeah, we're going to move from this. So these are not the techniques here. These are not the data preprocessing techniques, but this is what actually enables data preprocessing. Fit and transform, they are the key methods that enables data preprocessing in Sklearn. So in Sklearn, fit and transform are two essential methods used for data preprocessing, particularly when dealing with transformers. So transformers now are classes. Now I'm introducing some new concept basically. So when I say transformers, for those of us that are familiar with AI already, I'm not talking about the transformers architecture that is used in the AI products that we have today. We are talking about something different. We're talking about a particular data preprocessing method or technique. So they are actually, technically, they are called transformers because they transform your data from a format to another format. That's why we call them transformers, right? So as you can see here, these transformers are classes. So they're actually classes that learn transformation from your data and apply that to a new data, or and convert the transformation to a new data, right? So that's what transformers are. They are basically those data preprocessing technique, because when you want to apply those techniques, you actually have to import them, and they are usually imported most times as a class, right? So those class, they are called transformers. Those preprocessing class are called transformers. So for example, now when we want to build a linear regression model, we actually import linear regression from what? Linear module. So that linear regression we imported is a class. So the same way we did that is the same way we're going to import a preprocessing technique. And then we call that particular class we've imported a transformer. So that is why we have transformers here. So this fit and transform, they are essential methods when dealing with transformers. So there's let me just tell you something about understanding. The reason why we don't understand some concepts is because there's a particular word or there's a particular concept in that was used in explaining a particular thing that you didn't understand. So that concept just made everything it just made everything difficult to understand. So once you can actually understand that particular concept that is key to the concept, the general concept you want to learn, you're going to actually have a better understanding. So that's why I needed to explain this transformer so you understand. So I believe with this explanation, you already understand what transformers are. So when we are now working or when we are implementing, you don't start getting confused and all of that. Oh, what did he mean by transformers? So I've differentiated these transformers from a transformer that probably some of us don't know, but I'm just saying in case some of us already know those transformers. There's an architecture that is actually the state-of-the-art architecture that is used in AI now for like all the LLMs, all the stuff that we have today. So that is not the transformer we're talking about. So I just explained that, and I hope you've gotten it. Sometimes I feel I even over explain. Anyway, so moving on to the next thing, we are going to now look at fit and transform. All right. So I told you that fit and transform, there are two essential methods, right, that are used for preprocessing preprocessing your data, basically. So what exactly do they mean? So fit now is a method, and you know methods are functions, basically. It's just that they are functions that what attached to what an object. That's what we call them method. They're still functions, but they're still method. They're functions and method at the same time. So yeah. Responsible for learning the parameters necessary for the transformation process. All right. Let me repeat that again. The fit method is responsible for learning the parameters necessary for the transformation process. All right. So basically, what it does is that before you perform a particular data preprocessing, you actually call this fit method. So what the fit method is that it looks at your data and it kind of it looks at your data and creates an understanding of your data and creates a pattern in which it is going to transform your data based on that particular preprocessing technique you want to use. Let's say you want to convert your data to numerical to a numerical variable. You want to convert your categorical variables to numerical variable. We're going to look at that. You want to encode your categorical variable. When you import that particular transformer, right, you then assign it, or you create an object and then call the fit method on that object. So what the fit method does is that it looks at your data, your existing data that you want to transform, and creates a kind of transformation process. It kind of just understand, okay, this is the data. It's now going to figure out how to transform the data. That is what fit does. The fit looks at it, creates, let's just call it an algorithm, basically, that will be used to implement that transformation. So it doesn't do anything. The fit method doesn't give you any output. It just looks at your data, understand your data, and understand how to transform that data. Okay, so that's basically what it does. So the fit method is responsible for learning the parameters necessary for the transformation process, right? So it analyzes the data provided as inputs, calculates statistics like mean, standard deviation for scaling or threshold of business. So depending on the transformation or the preprocessing you are doing, it's going to just kind of create whatever is needed for the transformation process. If you probably want to calculate things or transform your data, like you want to perform, you want to like replace missing value, because it's also a preprocessing technique. It's going to like calculate things like mean. If you are using mean strategy, if you are using median, calculate the median. So no matter, depending on what you want to do, as little as calculating just mean is, the fit method would do that, and just it will do it and just keep it on hold, basically. All right. So it just performs the operation and keeps it on hold. It doesn't change. It doesn't apply it to your data yet. Okay. So these learned parameters are then stored internally within the transformer object. So all these things I'm saying, as we are implementing, you'll be understanding. So once your fit method has learned the necessary pattern, I don't want to use the technical terminologies first, just so you understand. So once your fit method has understand the particular pattern or the approach to use, then it will now like store it. Like, okay, this is how I'm going to solve this thing now. Let me keep it first, right? Because the fit doesn't apply, when you call the fit method, it doesn't apply those transformations to your data yet. So it stores it within the transformer object. So the pattern or the approach that I'm talking about is what we call the parameters, right? So the parameters are those things that it has learned when it looked at your data. So it's also a learning process. So I would say whenever you call the fit method, what you're trying to do, you're trying to help that particular, whether it's transformer object or it's an algorithm, you're trying to help it learn your data, basically. So that is what fit method does, okay? So in data preprocessing, it is learning parameters that will be used in transforming your data. So you can see the last point here is that the fit method doesn't modify the data itself. This is very important to know. the fit method doesn't modify the method itself. It simply extracts the knowledge required for transformation. That's for the fit method. Then after you've called the fit method, and after the fit method has done all these things, now you have to call another method, which is the transform method. So the transform method basically just carries everything that has been learned or that has been learned during the fit method or during the learning period, during when you call .fit, and applies it to your data. That's what transform does. So transform is like an action word. It's like an action method. Like, okay, I'll bring up this thing that has been learned and then apply it. So your transform method will always give you an output. When you call the transform method, it will give you an output, and that output is a newly transformed data. All right. So the transform method applies the learn transformation to a data set, and it utilizes parameters during the fit step to transform each data point. So this is exactly what I've been saying. So let's just say the fit method is like a noun, just a name of something. It really doesn't do anything. But the transform is like more of a verb. It does something, it's an action. So but both they depend on each other basically. The transform doesn't do anything internally. It just uses what has been done by the fit method and applies it to your data, so you can get a newly transformed data. All right. So it utilizes the parameters learned during fit to help transform each data point in the input data. So, okay, this is just an example, basically. All right. For instance, let's say you want to scale your data, right? So you first thing you do is to fit your transformers to your data, and then the fit understands how, because you're also going to like okay, let me just leave this example now because it might confuse you. So when we start implementation, I'll come back to you basically. But this is just an example of how you use your fit and transform. You can read it up. So that's it for the fit and transform. So the fit learns parameters, while the transform applies the length parameters to your data. So that's basically it about the fit and transform. So you can actually also use them together. You can use fit differently, use transform differently. While you can also use fit. So there's a method, a third method that is .fit transform. So obviously, based on my explanation, you already know what this .fit transform will do. So it will combine both of them and perform everything in one step. Instead of you doing it one and then doing it again. But there are situations where you use it, there are some situations where you don't use it, right? So in situations where when you want to you want to apply some transformation to several data, you can just learn the parameters and keep, and then you can now call transform several times. So just for you to understand, you just need to understand what these things do, and then implementation would not be a problem. So so you can use them together, as I've said. This method combines both fit and transform into a single step, and it's particularly useful when you want to perform the transformation in one go, especially if you are dealing with the training data. So yeah, I think I've explained that already. Now, this is just like a summary of our fit and transform. You can see we have three methods here. We have fit, we have transform, and we have what? Fit transform. So the fit here, you can see it learns transformation parameters from data. So that's the purpose. So we have method, purpose, does it modify data, and does it give an output? So the fit data, based on this particular explanation I've given, you can see that the fit data does not modify the data. That's why we have no here, right? It does not modify data. It only looks at data and learns from that data what to do or how to modify it, all right? So it is the transform that actually modifies the data. As you can see under modifies data, it's yes, so it modifies our data. And fit transform also modifies our data, obviously, because we have transform in it already. So the output, fit doesn't give any output. It just stores the stuff internally. While transform, yes, it gives an output. It gives you the transform data, and the fit transform also gives you the transformed data. All right, so this is just a summary of fit transform. Okay, so I believe this has given you an understanding of what fit and transform do in ML, right? So this is just a side note. Machine learning algorithms don't accept strings, so you have to convert everything to number. So most of the thing you'll be doing in preprocessing is converting your categorical variables to numerical variables to numbers. So it's very, very essential that you know this. It will give you an error, like you can't just pass it. So that's basically it about fit and transform. So we're now going to be moving into the different preprocessing techniques, the common ones basically, and how we can implement them. All right. So the attendance is on, so you can actually mark your attendance. Right. Okay. So the first preprocessing technique we have here is what? Handling missing values. Okay. So we've seen how we can handle missing values in what? Pandas. We can do exactly the same thing here, but with different approach, right? We're going to actually look at that. We can do exactly the same thing, but with a different approach. So we can handle our missing data in Sklearn. If you decide that, oh, let me just use Sklearn to do the handle missing values instead of pandas, you can just use Sklearn. So let's actually look at how that is going to be possible. All right. So first thing first, we import what the necessary do for the attendance should be open now. Has anybody been able to mark attendance? Please let me know. Oh, just give me a minute. Let me check. Oh, all right, it's open now. You can actually assign your attendance. Okay. All right. So first thing first, you import the necessary tool for the particular operation you want to carry out. All right. So in this case, we want to handle missing values. All right. So the particular class that we use to handle missing value is what we call SimpleImputer. All right, SimpleImputer. So to import SimpleImputer, we're going to come here, import SimpleImputer. So say from Sklearn.impute. So this is another module. I don't think we showed it in those list of modules, right? This is another module. It's called impute, import, simple. Sometimes I actually do forget some of these module names, so I just have to check it up. But if you forget, sometimes don't beat yourself up. It's normal because there are actually a lot of them. So SimpleImputer, you just do your shift and tab, you can see the the documentation. So this is what a univariate imputer for completing missing values with simple strategies. This is just what grammar. Now, first of all, this is a univariate imputer, basically meaning that what? Can someone just tell me what this means? Like one thing about being a good data scientist is ability to read and understand documentation, right? So in this case, what do you think they mean by univariate imputer? Because sometimes we tend to read this documentation. Still yet, documentation that's supposed to help us understand would end up convincing us. Yes, what this univariate imputer mean is it can only work on one variable at a time, right? One variable, basically, right? It works on one variable. So you can now start understanding how it works from even the documentation, okay? So this is a univariate imputer for completing missing values with simple strategies. So what strategy in this case mean is how exactly you want to handle these missing values. Do you want to get the mean, or do you want to use median, or whatever it is? So strategy here, if you actually scroll down, you see strategy. So strategy is the imputation strategy. So if you select mean, which is default, then the particular transformer is going to calculate the mean of that variable and replace those missing values with the mean. So that's basically what this one does. If you select median, or if you choose median, it replaces them with median. If you choose most frequent, obviously this is the same thing as mode. All right. If you choose constant, then you have to define the particular constant value. So constant mean you want to specify a particular number that would be used to replace it. Okay, so you can replace it with either strings or numeric. So that's basically for that. So we have some parameters here. We have missing values. We have strategy. So this is like telling us that this value that we have here is what we use in representing missing value. So in this case, you don't usually impute this. You just leave it because that's the default, basically, unless your missing value is represented by something else and you want to specify it. So your strategy by default is mean. If you want to change it, you can change it. Okay, so these are the two parameters you'll be using most frequently, right? So these ones, they are like, if you want to play around, you can check them. So basically, this is how you do your SimpleImputer. So let's just quickly import the data set and use that. So I'm going to import pandas. Import pandas as PD. So file name. How can we get to the show? Okay, so after I can import this. This is not here. So I have to open a new one here. Just give me some minutes. So customer bookings CSV. All right, so we're trying to see how we can just use the data set to demonstrate these different techniques that we're going to be explaining. All right, so let's just pick up what we've done in the previous place. All right, so come here and customer bookings.csv. So here first bd.read CSV and not my file. All right. Okay, so I'm taking my time. All right. Okay, so this should run fine, and then you can see this na.sum. So we can see that we have several missing values here in our data set. So we'll try to just demonstrate that we can use our SimpleImputer. So let's quickly do that. So we've imported our SimpleImputer, right? So remember, I've explained the fit and transform. I told you that when we use fit and transform is when we actually want to use a particular transformers or a class, might be an algorithm or whatever, but you import your particular preprocessing class. So in this case, we're importing SimpleImputer. So SimpleImputer is what we're going to be using to work on our missing values. So first thing to do is to create a SimpleImputer object. All right. So this is the same way we created linear regression object, logistic regression object. So whenever you import a class, and you know a class by the kind of case that you have there. This is a what kind of case is this again? What kind of casing is this again? This is actually important because I think at this point it's still confusing some persons. What kind of case is this again? All right. Who said Pascal case? Okay, this is a camel case. All right. So whenever you see camel case, especially in Python, you are looking at what? A class, right? Whenever you see a camel case, you're looking at a class. So when you import a class, the obvious thing to do is to create an object of that class. So in this case, I'll create an object. I'll just say imputer or impute, and then I'm going to say simple imputer. So obviously, the class is going to have some parameters, right, that you have to specify. So we have our strategy here, right, and let's just leave it empty, right, because we don't want to change anything. We really don't want to change anything because what we needed is already there. Okay, so we're just going to So I'm just going to use this straightforward. I'm going to use it. So let me see. All right. So now let's try to work on these variables that we have here. So we have this sales channel here. We have trip type. We have purchase lead. So let's look at sales channel. I think we should have done that before we even created this object here. Let's look at sales channel. So safety sales channel. So this is a categorical variable. All right, this is a categorical variable. So you obviously are going to use a different method, a different approach to filling in or handling this missing value. So because of the nature of this variable, we'll have to change the strategy, right? So instead of using the default strategy, which is mean, we're going to change it to be what? Most frequent, right? So if I come here, I'll just say strategy equals to most points. All right. So you can see now that this is now going to change how the SimpleImputer would work. So it's going to now look at, so once I do this, next thing to do is just to come here and say impute. This is the object I've created, right? So I will now use this object to call my fit function, .fit. And then I'll pass in my data. So my data here is what? df.sales channel. All right. So once I run this, it's going to look at so let's see what error. Okay. So now there's something I need you to understand. When you're calling the fit function always expects a two-dimensional object. All right, it always expects a two-dimensional array. Let's use array. It's always expected two-dimensional array, and this our sales channel is a one-dimensional array. So to solve this problem, you can just put this in a bracket. All right. So this is going to act as the outer bracket, making it two-dimensional. So most times when you're passing a single dimensional array into a fit, put it into a bracket, right? So it can become a two-dimensional array, right? Because if you don't do that, it's going to throw an error, right? So either do that, or if you pass in, let's say, more than one variable, then it's going to actually work. All right, it's going to work. But in this case, we're going to have an error. So we have to do that. So you can see that this fit now, it has actually kind of looked at the data that we passed in, understood the data structure and data type, and understood how to apply this strategy, right, to the data. So what it does is that it calculated or it checked the mode, the most frequent value in this particular sales channel, and it discovered it and it stored it internally. And it was like, okay, when the transform method is being called, the transform method should use this particular most frequent value to replace the null values or the missing values. So that's basically what has been done. As simple as this thing sounds, this is what the fit method is doing in this case. So it can become complex depending on the kind of transformer you are using. So in this case, our input, this input here is called the transformer. So this is the transformer. I remember when we were looking at explaining this, where is that? Okay, exactly. I said in Sklearn, fit and transform are two essential methods used in preprocessing, particularly when dealing with transformers. So these transformers here, in this case, an example is this SimpleImputer that we just created here. So this is a transformer. So we apply the fit method to this particular transformer here because what it is transforming our data from a data set with missing values into a data set with no missing values. So once I've done this, the next thing I'm going to do is what? Input dot transform, right? And then I'll run. I should have just done it in a new. Okay, I should have just done it. So I'll avoid running this thing again. So I'll come here and say input dot transform, and this transform takes in the same argument, which is your data that you want to transform. So you just pass in your data here, and then you run transform. So you can see here that it immediately returned an array. All right. So this is like just showing you exactly what we talked about. That the transform actually return a transformed value. So if I come here, I can now pass it into a variable. I can now say transform, or sales channel new, or I can pass my df.sales channel. So I can say df.sales channel, and I'll pass it to it. I don't know why is it taking this much time. So basically, that's how you use your fit and transform on a particular transformer value. All right. So just leave this and pass it to new sales channel. So if you do this and you come and say new sales channel, you're going to have this array. So the reason why we had the particular error was because the value that this transform method return is an array, and you need to just do some extra step before you can pass it into a data frame, right? But this is what you get. You get an array basically. So you don't have any missing value here again. So you can now like probably apply it. If you are working with the data frame, just apply it back to this particular column you have here, and then you can repeat it for each of them. And I think you can actually perform. You can try that on your own. You can like try performing this on your categorical variable separately and numerical variable, but you have to actually do it you have to do it individually. So you just pick each of them individually and perform the SimpleImputer operation. So that's basically how you do SimpleImputer or replace missing value. So if you're working with, let's say, a numerical variable, the only thing you have to change here is this strategy. So you have to just leave it as a default value, which is the mean or median. All right. So you just keep it this way. The times you're going to need to use median is when you have outliers. you have outliers in your data sets, you can use median, so your mean value is not skewed, right? So that's just it for SimpleImputer. You can see how straightforward the implementation is, right? You can just do this on your own. Call the SimpleImputer from the input module here, all right? Create a SimpleImputer object, call the fit method on the transformer, right? And pass in the particular variable you want to transform, and then transform it. So you can either do it this way or you can do it the other way. So you can use the fit transform method directly. All right. So you can just come up here and say input.fit transform, and then you pass in your data here. So there's something I'm going to show you now. We're going to try to use, we're going to try to use most frequent here. I'll run this and try to apply it to what's the parameter? Okay, so we'll try to use most frequent here and I'll apply it to a numerical variable. So you see exactly why it won't work. So let's use length of stay. I think this is a numerical. So you can see the fit transform has given us the same output here. So you can either use it together or you use it separately. All right, so that's basically how you use your fit and transform methods. So let's look at how we would apply that to a numerical variable. So come and say, okay, let me just put it here. Length of stay. So length of stay should be numerical. Yeah, just confirm. Yeah, it's numerical. All right, so if I run this, using this strategy, oh wait, okay, let's see. So you can now decide on your own whether you want to use the pandas missing value technique or the Sklearn missing value technique. So either way, whatever you're comfortable with, you can just use it. So the ball is in your court. So, but this is how you perform or you handle missing values in Sklearn or with Sklearn. So one thing is that once it starts taking a lot of time to run, just know that it has run into an error and it's trying to understand where the error comes from. That's why it's taking a whole lot of time. So obviously this won't work. So, but that is just it for SimpleImputer. So the next preprocessing technique we have here, we've looked at SimpleImputer already. So the next we have what we call encoding categorical features, right? So this is actually something that you're going to be doing very, very often, because this encoding part is when you have, like, let's say, categorical features like the text or strings, and you obviously need to convert them to numbers so that you can work, your algorithm will be compatible with them. So this is another preprocessing step in machine learning, right? So there are several techniques that we have under this. We have label encoding, we have one-hot encoding, right? And we have ordinal encoding. So we have these three encodings here. We have label encoding, we have one-hot encoding, and we have ordinal encoding. So we're going to actually look at these three, and we're going to see how to implement them in Sklearn. Right, but before we do that, I think we missed one particular strategy, which is for SimpleImputer, which is constant value. So we can actually just include the constant value here, and it will impute or replace our missing values with the value that we specify. All right. I don't know if it's necessary to demonstrate that, but I feel that is quite straightforward. So we can just let's see. You can see that this is still running. I don't know which kind of error I run into, but anyways, let me stop it. So you can see, okay, this keyboard in the if I change this to mean, I come here and do this. You see it worked, right? Because the strategy is now aligning with it. So it's very important for you to take note of that. So for your constant value, so all right. So if we want to use constants, we just come and say constant, and then we specify exactly what we want to fill. So we have fill value, and let's say we want to change it to whatever, let's say 56 or 56, then we include it there, and then we run, and then we run it. Okay, this for sales channel. We'll come here and run it. So we are actually going to obviously get the 56 replacing all the missing values here. We can't really see it because we're not seeing everything here, but the 56 here has actually replaced all our missing values. So these are the different ways to work with missing values. You can use your mean, your median, your most frequent, and you can as well use a constant value. So when you indicate or specify constants in the strategy, you have to add a new argument here, which is your fill value. So this fill value will be whatever it is you want to replace the missing value. All right. So this is very straightforward. I don't think there's any more to this, right? So that's it for SimpleImputer. So the next thing we're going to be looking at is how to encode our categorical variables. All right. So let's have it here. Encoding categorical variables. All right, so for categorical variables, I mentioned that we have several techniques for doing that. We have our label encoder. We have our one hot encoder. And we have our ordinal encoder. So these are the three different encoders you are going to be using, but the most common ones are going to be your label and one hot encoder. Okay, so these two are going to be the most frequently used encoding technique in Sklearn. So ordinal encoder is the same idea with the ordinal linear regression. Linear logistic regression, where there's an order to it. So whenever you have when you're working with a data set that has order to it, the same way we explained for logistic regression, you use your ordinal encoder for it, right? But now let me just quickly give you the instances when these things are used. So label encoder is used for labels most of the time. Labels or targets variables. One hot encoder is used for your features. Ordinal encoder is also used for labels or target variables with order that have order basically. So label encoder and ordinal encoder, there is that basically the same thing, right? But the difference is just that label encoder are used for those labels that has order to it, right? And there's a kind of hierarchy basically, the same way I explained in logistic regression. But one hot encoder is used for your features. It's used when you have categorical variables in your features, right? And you want to encode them. You use one hot encoder. For label encoder, it is used for your dependent variables, basically. All right. Your ordinary encoder is used for your dependent variables as well. But sometimes you'll see some people using, or some persons using label encoder for their features as well. All right. So that like, it's not like it's not going to work, but this is how it was designed for. This is what it was designed for, basically. So these are the 3 different techniques for encoding categorical variables in Sklearn. So let's look at how we can actually use them. All right. So going back to this, we have label encoder. So what it does, it assigns numerical label to each unique category. Okay, very straightforward. So it looks at each unique category and assign a unique category, sorry, a numerical label to them. All right. So as you can see, the label encoder should be used for the target variable. Okay, it should be used for the target variable. And the same way we fit and transform SimpleImputer, in the same way we can impute, use and fit and transform for label encoder. So the pattern is the same for most preprocessing techniques in Sklearn. So as we have it here initially, where we looked at the different key features of Sklearn, we said Sklearn is easy to use. So the consistency in its use is what makes it very easy for beginners, right? So if you just understand those steps, import the class that you'll be using for transformation, create an object, right, and include the necessary parameters and what have you, and then go on to fit it to your data and then transform. Right. So that's just the step that's the step we'll be following most of the time when working with our preprocessing technique. So let's look at how we can do the label encoder quickly. So you can see here you have to import it from the module preprocessing. So we are going to be using the preprocessing module for label encoder. So let's come up here. So import label encoder. All right. So I'll come here and let me just come up here and do that. So remember, you import everything in the same cell. It's a good practice. Import preprocessing. Import label encoder. All right, so you can see that this is going to be imported. Now, if you do your Shift and Tab, you're going to just see a brief documentation of what it does. So it encodes target labels with values between 0 and n classes -1, whatever. So that's basically what it does. It just assigns a numerical value to the number of classes you have. So you know why this -1 is there, right? Like, I know this is so, like, can someone just quickly tell us why we have n classes -1? This is an obvious answer, but I just want to like see the responses. Because as simple as this is, it might be some person. Hey, why didn't they just say n classes? Why did they say between 0 and n classes -1 here? Like, there's something I need to tell you. Being a data scientist is like, it has to do more of how you think or how you interpret things, right? So you have to be very flexible in your thinking, right? So yes, it's the last class excluded, obviously, but why do you think they have to do -1? Anyway, because of time, the reason why it's -1 there is because it's the index. We are starting from 0. So let's say we have we have 4 classes, right? We have apple, banana, apple. We have apple, banana, and orange. 3 classes basically here. All right. So these are the unique classes. So, but these are just like the data set having multiple duplicates. So let's say we have these 3 classes: apple, banana, and orange. So the number of classes here is what? 3. Okay. Let me just copy this. The number of classes here, we have 3 unique classes, okay? we have 3 unique classes here, and n is going to be what? N classes is going to be equal to 3. So what label encoder does is that it encodes your classes with values between 0 and n classes minus 1. So in this case now, let's say we have our first class here. The first class here is going to be n classes minus 1 is now going to be n classes minus 1 is going to be what? 2. All right. So we have 2 here. So you just think this now, you might be like, oh, we're having 2 here, but then we're having 3. So how is it going to assign classes? The simple reason is just because the labeling is starting from 0. So our first class, in this case, which is probably, let's say Apple, is going to take the label of 0. Our second class, which is Banana, is going to take the label of 1. And our third class, which is Orange, is going to take 2. So you can now see why we had n classes minus 1 here, because if you look at the labeling, it's going to end with n minus 1, which is 2, because what the labeling starts from 0, it doesn't start from 1. That's why we had this here. That's when we looked at the label encoder here. When we looked at label encoder, it has encode target labels value between 0 and n classes minus 1. All right, so this transformer, you can now see what I was talking about. This is called a what? Transformer. This transformer here, which is label encoder, should be used to encode target values. That is why, like you can see now that this has been emphasized a lot, like in this class. Like we should use it to encode target values and not the input value x. All right. So when you have a target value that is a categorical variable, you would use your label encoder to encode it, right? So that's basically it. If you're working a logistic regression problem or a classification problem, let me not use logistic regression because there are also other algorithms for classification. If you are working a classification algorithm task, and your categorical variable is in categories, then you have to encode it. It is a must. You have to encode it to a numerical value before passing it into your algorithm, right? So you can see the other ones here. We have ordinal encoder, right, which encodes categorical features using an ordinal encoding scheme. Okay. One hot encoder encodes categorical features as a. So I think we have to check this again. Ordinal encoder I think it can also be used for features as well. So yeah, that's it for label encoder. So let's see it in action. We're going to. So we've imported it already, right? So we're going to create a label encoder transformer object. All right. So I'm just going to come and say encode. I'll say label encode. I'll say label encoder. I don't think you need to put any parameter here. All right. It just does it automatically without any parameter. So you created an object, and then the next thing to do is to like feed the transformer to your data. So you come and say lab encode dot fit is what. So let's look at one of these values here. Let's see the data set. Let's pick up one. Head. Okay, we'll just assume that this strip type is our target variable, is our label. Let's just assume. So we're going to use strip type as our label. So we want to encode our label strip type. So I'm going to come here and just label equals to df dot script type. I'll come here and do label. All right, so before I run this, I need someone to tell me if there's anything wrong with my code before I do that. There's actually something wrong with my code, but I want us to point it out before I run it. Just take a good look at it. What am I missing here? Thank you, Joanne, Luxin, and Emmanuel. Exactly. I have to put in my bracket here, right, to convert to two-dimension. All right. I have to put in my listing to convert to two-dimension. So it's very, very, very important. Very, very, very important. You can either do this or you can use reshape, right, by importing np and saying np.reshape and then put your stuff there, reshaping it to two-dimension. So you can just do it this easy way. All right, so I'm going to why should be one? Okay, so we're going to just go back a little. Now, for this particular label encoder, I just remembered, since it is used for our labels, right, our target labels, it's expected that our label is in one dimension. So this doesn't apply to this particular transformer. Like it's an exception, right? For this particular one, since our label is expected to always be a one-dimensional object, it doesn't receive a two-dimensional object in the fit method. So it's very, very important to note, like very, very important. So I think the idea of two-dimension doesn't apply to this. So, but when you're using other transformers, you would make sure that you convert to two-dimensional. You add a bracket so it can become two-dimensional. So that is actually very important to note. So we run this, and you can see that the fit method has automatically learned our data and understood how to transform it or apply transformation. So I have to come here and apply the transformation itself, and just call the transform method on our data. So you can see now that we've transformed our data to numerical variables, right? So we had why is that data set again? That is trip type. We had our df trip type to be categories. All right, now it is what numerical variable. So you can just go on and check the data itself, but that is not the point of this class. Just to show you how we can use the different transformers, right? So you've done that. Now you can now start working with your data and use it in building and creating your model, right? So that's it for that. So most times when you do this, you just assign it back to y. So you assign the output to your y variable, which is your label. And after you do that, you then move on to splitting your data. So these are some of the kind of transformation that you carry or you perform on your data set. So that is for label transformation. So we also have other transformations like one hot encoder. So we have what we call one hot encoder. So one hot encoder is a very popular encoding technique for categorical variables. Emmanuel, you asked, how does it know what numbers to assign to the categories of the variable? That is part of the fitting method. All right. So when you call fit, it calculates the number of classes. Right. In this case, number of classes. I think we have 3 of them. So it calculates them and subtracts 1, and then it gets the numerical representation or the numerical representation of the categories we had before. So the way it is arranged, right, the way the unique values are arranged, I think they are sorted. So from in alphabetical order. So it just sort it in that way and then assign the numerical values to them. Since there is no ordinal arrangement, there's no ranking, there's no hierarchy to the label. So there's really no it doesn't really matter what number it assigns to it. It just what matters is that it assigns it labels those correct categories with its unique number. And wherever that particular label appears, it replaces it with that number. That is all that matters, all right? So the order of the label, if there's no order to your label, it doesn't really matter how it assigns a particular value to it. What matters is that it assigns the numerical variable to each label and replaces it wherever it sees it in your data set. That is just all that matters, right? So I don't know. I think that should answer your question. So for one hot encoder, what we do here is basically replacing the categorical features with numbers. So this is quite different. This is not the same thing as label transformer. The idea is not the same, where it looks at each category and then gives it a specific number. No. One hot encoder is different, and I'm going to explain that in a minute. But before we do that, let's just import the one hot encoder. So you can either import it like beside label encoder and say one hot encoder, or you just import it freshly. So probably if you're not importing a lot of things, you can import it fresh, so you don't clutter everywhere. So I can come and say one hot encoder. So that's it for that. You can just check it out. Your shift tab. All right, let me run this. The shift tab, and you can see that it does what? It encodes categorical features as a one hot numerical array. All right. So the input to this transformer should be an array like of integers or strings, containing values taken. So these are just explanation of how this works. So now let me give you an idea of what happens during one hot encoding. So one hot encoding is a technique itself. All right. So let's assume you have three categories. Like you have category 1, let's say cat 1. You have cat 2. You have cat 3. Right? So these three categories, they belong to one feature. So let's just say feature 1. So we have feature 1 basically. So for one particular feature, we have three categories, and we want to convert this particular feature or variable or column to a numerical variable, right? So what one hot encoder does is that it takes each of these categories and converts them to a column. All right. So remember, initially we have a feature, right? I have three unique categories. If you want to apply or you want to convert these categories to numerical variables using one hot encoder converts each of these category first to a column. It doesn't assign numbers to them the same way label encoder does, right? It doesn't just count the number of categories here and say, okay, n classes minus 1, this one will be 0, this one will be 1. No. It converts each of them to a category first, and it then give it by two, either of these numbers, 0 or 1, depending on the particular observation, or depending on the particular row, right? Let's just say we have like 100 rows in your data set, right? And in those 100 rows, you obviously have this particular feature, and then have this, you can have either of these categories. So let's say in your first row, you have category 1. So let's say it is something like this. Let me see if it's possible to, let's say row 1, row 2, row 3, row 4. All right, let's just say something like this. And we have, this is our index, obviously. All right, so we have feature one. Feature one. We have feature, let's just use two feature for now. So in this row one, we have our feature one has cat one. Let's say row two has cat one. Row three has cat three. Row three, this one too has cat three. So this is how your data is arranged, right? So I just neglect this feature to whatever it is that we have here. So this is the original format of our data. And then because our algorithm can't take in numeric strings or text as input, we have to convert this our feature one, right? Let's just say this feature two is a numerical variable. Let's just put it like this. Let's just say it's a numerical variable. I want to help you visualize this well. Okay. So this is our data set, right? We have 4 rows here and we have 2 features. I want to convert this feature one to a numerical variable. So, and we use one hot encoder. One hot encoder doesn't just slap numerical values to each of these categories here. What it does is that it converts each of these categories, like it gets the unique categories first and it converts them to features. So once we apply, let me just come here, after applying one hot encoding. So this is before one hot encoding, all right? So I'll come here and just copy this first. Oh, don't worry. So this is your index. You have your row 1, you have row 2, you have row 3, you have row 4. Row 4. So now, when you apply it, this particular feature one is converted to, each of these categories here will be converted to features now. So instead of having feature one, feature two, we are going to have cat one, cat two, cat three, and then we have feature two. This is exactly what one hot encoder does. It will convert the categories, right, in this particular feature to features themselves. And after it has done that, you now apply or check each of these feature now, or the newly created column, to know which what was the original value in that particular row. So for this row one, we had cat one to be the value. So in this case, it's now going to assign one. It's going to assign 1 to that cat one and 0, and then 0 to cat 2 and cat 3. All right. For row 2, we have cat 1, so it will assign 1 and then 0 here and then 0 here. This is what we call one hot, meaning that when you look at each row, you are going to have only one category or one column with number 1, right? Well, number 1 basically means this is the particular value that is in this row. Okay, so for this row 3 here, we're going to have 0 here, we're going to have 0 here, and we're going to have 1 here. All right, so the same thing is going to happen here. We're going to have 0 here, we're going to have 0 here, and we're going to have 1 here. Let's assume we have row 5. And row 5, let's add another row here. Row 5 here, and we have cat 2. What's going to be the one hot encoding for row 5 here? I need responses. So this one is for you guys. What is going to be the one hot encoding for row 5? This one would be 7 plus 6, 54, 82, 90. Perfect. This basically means that we have understood what I'm explaining. So it's going to be 0, 1, and 0. All right. So this is going to be the exact representation of our feature 1 colon when we apply one hot encoding. So one hot encoding basically convert. Now the thing is, if we have, like, let's say 10 categories here, we're going to now have 10 new columns. Okay, we're going to have 10 new columns, and each of the columns is going to be one hot encoded, basically. All right, so that is what one hot encoding means. It is quite different from label encoding, and it is used for our features or independent variables. So it has done this for feature 1. If we have another feature that is categorical variable, and want to do, it's going to do the same thing. Convert all the categories to new features, and then apply one hot encoding to it. All right, so that is basically what happens in one hot encoding. Hope we are still following. Hope everyone is still following. Hope you hear me clearly and you can still see the screen clearly, and you are grasping what we've been discussing and explaining so far. All right, perfect. So let's see how we can implement that in with our data set. So we have DF here already. So we're going to use let's use strip type. Okay, let's use strip type again. We're going to use strip type. So let's have a strip type variable. Strip equals there dot strip type. All right. So encoding variable with one hot encoding. So what's the first thing to do here? First thing first. So I think you all will put me through this, right? So what's the first thing I need to do here? All right, only one person, 2 persons. I create an object. So I'll create a one hot encoder. So one hot encoder, one hot. So I'm going to have one hot encoder. So there are some arguments that we need to look at in one hot encoding. So we have we have sparse output. So this sparse output is something that you would need to specify sometimes. So it was previously sparse. It was converted to sparse output. So let's quickly look at what sparse output does. So we have sparse output here. We have sparse. Okay, I just want to get some. I want to confirm some things first. Okay. So sparse output basically is actually a way to store your matrices. All right. I'm trying to see if there's a way I can just explain it with an example. Um, Anyways, let's just keep that. But just know that you always like include sparse output. So sparse output, when you set sparse output um, um to be true, it returns a kind of object which is not necessarily an array, right? It is a kind of SciPy sparse matrix, all right? When it is false, it returns a dense NumPy array. I don't know exactly how to explain that right now, but just keep that at the back of your mind. So by default, the sparse output is always, don't let the sparse output confuse you at the moment. Just keep it by the side. It's really not important, right? Just keep it by the side. So sparse output is usually true by default, but we're just going to leave it. Let's not mess with that for now. So once you create the object, then you fit it with your fit method. There are just a lot of things to look at or to explain in this. So picking out the ones that are important, and then you put in your trip. So you've created your transformer object and you've fitted it to your data. So then you transform, come and say one hot dot transform, and then go to trip as well. All right, so that's basically what you see. So this is the sparse what I mean by the sparse matrix. So it's kind of an efficient way to store your one hot encoding value. So the thing is that, like, based on this example I gave you here, where is that? Based on this example I gave you here, you notice that this is actually going to be a problem when you have a lot of categories. Let's say you have 50 categories now. Okay, you have 50 categories. Your one hot encoding is going to create 50 new columns. And let's just assume now that you have like 50 columns, or let's just say you have 10 columns, and out of those 10 columns, you have, let's say, an average of 5 categories per columns. Now, if you perform one hot encoding on each of those columns, you're going to have a you're going to have a lot of features, basically. You can even have up to like 500 features because each of those categories will be converted to columns and all of that. So it can actually consume a lot of space if you store it exactly as it is in the memory, if Python stores it like that. So what sparse output does is that it kind of changes the way it is stored by not storing it as 000010000. So the nature of the data is being converted in such a way that the Python only remembers where there is one, right, and then stores it that way. So when it is retrieving it, it can retrieve it back in that format, right, instead of saving it as it is here, right? Because if you save it as it is here, because you're working with just small data at this point, that's why we can easily just do it. But if you're working with a lot of features that have a lot of categories and they have a lot of unique categories, right, you can now see where the problems start to come in. So that's basically what sparse matrix does. It just, I think it's something they added to just make it efficient. So if I come here and say sparse output, let's just change it to false. And let's do this here. Let's transform it. So this will take some time. Anyways, but that's just it for one hot encoding. That's everything basically you need to learn one hot encoding. So you can see the output here, right? So this is actually our one hot encoding. So everything that you do is usually returned as a NumPy array, basically. You can convert it to pandas data frame like later on. Like, I don't want to waste time on that, right? But just a quick little tip for you. If you want to convert to a data frame, you can just choose your normal data frame, and then you need to get the columns, right? So there's something that is being stored internally, right, in your transformer object. So it is called then gets feature names, features out. I think out should be there. I've forgotten some of those things, right? But you can see now that it has actually stored the feature name for each of those outputs or each of those new features, right? So you can see round trip, the second one, the third one, till this. What exactly happens here? So is round trip not? Let me just open something. Make. Exactly. All right. Don't mind me. Like we're actually done with one hot. I'm just trying to confirm something. So that's it for one hot encoder. The next one we have is ordinal. So ordinal basically is a way to like encode your data, right? But it's quite different from one hot. It takes the same pattern as where's your ordinal? The same pattern as your label encoder, right? So it assigns numerical values that reflect the orders of the category, right? So there's how it actually does it. So it looks at the different categories and just encodes them. So you indicate your categories, right, in the arguments of the class, and then put it here in a bracket and just performs all of that. So it assigns a value to each of the category. So that's it for ordinal. It's not very commonly used, so we're not going to like look at it. So the next thing we have here is scaling features. So we can also scale our features, right? So feature scaling is also another preprocessing technique in Scikit-learn, right? So what scaling means is that you want to bring your feature. Let's say you have it's used for numerical feature, right? So let's say you have a lot of you have one particular numerical feature that has a high range of values, right? Some of them are in the thousands, some of them are in millions, some of them are in hundreds and all of that. So you want to bring them to be in a particular scale. right? So your ML will perform when you have a very, very minimal range of scale of a particular numerical feature rather. So if you have like a feature that has wide array or wide range of numeric numbers, you're going to actually, it's going to be more difficult. So it's going to take more time for your algorithm to learn well and to probably affect the performance of your model. So you need to always scale your features, right? You need to scale your features. Scaling features basically means bringing them to a range, usually between 0 and 1 or between -1 and 1, right? Depending on the kind of feature scaling technique you are using. So for feature scaling, we have several types. We have normalization and we have standardization. So these are the two basic type of feature scaling. So we have the normalization. For normalization, we use what we call the min-max scaler. So you have to import that obviously from the preprocessing module. So once you do that, and this is used for just your numerical features. All right, this is useful. So yeah, these things, they don't just work for any particular type of data variable. You have to know the kind of technique you are using, the kind of technique you're using and how it is applied, right? So for your encoding, it is for categorical variables, while for your scaling, it's for your numerical variable, right? So you can either use your normalization or your standardization. So these are actually statistical mathematical concepts, right? So that have been implemented or packaged in Scikit-learn. So for normalization, we use what we call min-max scalar. So there's a formula to it. You can actually define it yourself, right? But everything has already been packaged for you. So you use min-max, and then you do the same particular step. You get your data, all right? So let's say this is your particular X variable. You can see here we have one of them is 1,000, the other one is 2, the other one is 50. So you use your, so we're going to actually look at it, but I just want to explain it first. So we also have standardization. So standardization is another method that is used for scaling our data. So you import what we call standard scalar from the same preprocessing, all right? So we can use either of these two. We can use min-max or we can use standard scalar, all right? So basically that is how we preprocess our numerical data, or that's how we scale our numerical data. So it's actually quite straightforward. You have to import them from preprocessing as well. So you can see that a lot of all these classes we have or we've used are from the preprocessing library. So when you are preprocessing your data, most of them will come from this particular module, and our imports and standard. That will import all of them again. Min-max rather. Min-max scalar. All right, so you import this. So if you just look at each of them, you'll see that the standard scalar standardized feature by removing mean and scaling the units to branch. So this is the formula here. I told you it has a formula. So x minus mean over standard deviation. All right, so we will subtract the mean from each of the feature and then divide everything by standard deviation. So it's a normal statistical formula. All right. So if we have min-max transforms features by scaling each feature to a given range. So you see this is the formula here, right? X standard, X minus S mean, this data, and all of that. So now you might be asking, when do we use min-max scalar and when do we use standard scalar? So if your data, remember I've taught us histogram, and I mentioned standard distribution, normal distribution rather, and all of that. So if you access your data, that particular numerical data, and it is normally distributed, right? It is advised that you use your standard scalar, okay? If it's normally distributed, just go for your standard scalar. If not, you can go for min-max scalar. So if it is not normally distributed, you can just use your min-max scalar to scale your data. So that's basically the what determines which of them you use, right? But for most of the time, if you use any of them, it might work, right? But when it start like giving you maybe affecting you, you now have to go back to check affecting the performance of your model. You have to go back and check this thing I just explained now. Is this particular variable normally distributed? And if it's normally distributed, am I using standard scalar for it, right? So that is basically how you use your standard and min-max scalar. So the same process follows for that. You import your standard scalar, create an object, create a standard scalar object. So just a standard scale. All right. So then fit it to your data. So pick one of the data that we have there. Let's see. So let's just pick purchase lead. All right. Or let's see if there's another one. Okay, let's pick purchase lead, right? Let's pick purchase lead. Let me just use fit transform immediately. Fit transform. df the purchase lead. All right, so it has actually scaled our data. So if I come up here and just say scaled, all these things are just warning. All right. So come and say scaled. And all the shapes of So I'm trying to just visualize you like majority of, so you can, I want to show you the other values because it's kind of truncating all the other values. Like 0 point something 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 0 point, so it's just truncating it here. But let me see, what is the actual this thing again? Scale the shape. Anyways, I don't know why these things are just giving me headache this afternoon. But that's how you scale your data, right? Once you scale it, you get an array that you can now use and proceed with what you're doing. So tomorrow we are going to now move on from taking the preprocessed data and then finish up with the remaining steps, right? Looking at how we can like split it. Remember we split it before in the last class, so but this is a different approach we've taken. So after we've gotten our data, because some of us might be confused on how we would make use of all these things. So because I didn't want to focus on that, but because of time, right? So we'll just look at that tomorrow. So after you've processed your data, how do I now like combine everything and then pass it into my train test split and also pass it into my model for training and all of that. So we'll wrap up with this tomorrow, and yeah, we're going to we'll definitely finish up with it. So this is for standard scalar. You get that for min max, you just replace this with min max scalar. And you can just say, come here and say min max min, max, scale. So it's going to give us the same thing actually. So all these values you're going to be having here, you can see that they've been scaled to like very, very small values, right? Between 0 and 1 basically. So the initial value for our purchase lead was all these things we are seeing here, but they've been converted to very, very small numbers. So that is what we call scaling. Scaling, you can either scale something to be very big, or you can scale it to be very small. So that is the essence of scaling your data, to bring it to a very, very small range, right? So your algorithm can actually like it can make it easier on your algorithm basically. Right? So those are the transformation process or preprocessing techniques you most likely be doing, right? So we looked at 3 of them generally. We looked at SimpleImputer, we looked at our encoder, and then we looked at our scaling as well. So there are some other ones that we have, but these ones are the most common one that you'd have to mostly perform on your data, right? So SimpleImputer you might not necessarily use because your data might have been cleaned in pandas, and then you just want to like encode it with Sklearn. Some of these things that you can do here, you can actually do it in pandas, right? You can perform one hot encoder in pandas, but in pandas it's called something like pd.getDummies. So you can check it out. So pd.getDummies would kind of do the same thing as one hot encoding. So I'm not sure about scaling, right? But I know about one hot encoding for pandas, right? So these are the most commonly used preprocessing technique. So we have some other ones, right? We have feature binning, we have feature selection, we have feature transformation, we have dimensionality reduction. So these are some of the other techniques that we would perform. I think this is going to be the last class. In our last class, we're going to look at dimensionality reduction. We're going to look at feature selection. Right, so we'll look at some of those things in the last class. Definitely we'll pick out time for that because we still have like 2 more topics to look at. So that's it for feature selection. So after you, that's for feature engineering or preprocessing, right? So after you preprocess your data, you then go ahead to split it, right? And then carry on with the next steps that we've looked at already and train your data. So there's a lot of work usually in the steps preceding your model training. All right, so you would have to look at some things. You have to like encode and all of that. So sometimes it might just give you like tough time and all of that, but you have to ensure that you finish up or you make sure that your data is in the accurate or appropriate format for model training. Okay, so that is it for this class, right? We've overshot already, as I said. We're going to continue from here tomorrow. And we're going to look at how we would proceed with the data we have. So tomorrow is going to be more like an end-to-end class or an end-to-end practice or implementation. So we're going to start properly with a particular data set, clean it, transform it, and then build a model with it. So I just needed to introduce the preprocessing steps to us today. So tomorrow we go over that properly, and we have a holistic idea on how to approach this kind of task whenever we are given, like ML tasks, basically using Sklearn. All right. So we're going to do that tomorrow. Hopefully, complete that and move on to the next thing next week. So tomorrow I'm also going to give you your projects, all right? So the project will be going on as well as the class. So I would encourage you to start it as soon as possible so you don't get choked towards the end. So the project lasts for 2 weeks, but I might actually maybe extend it a little bit, right? I might extend a little because our class might overshoot, right? Let's say by a week. So the project might last for between 2 to 3 weeks, right? So then I think that should be sufficient for you to finish up with it. Okay, so that's going to be it for today's class. I'm going to be joining the curtain here. I know many of us have left already, which is understandable because we all have plans and all of that, but the recording will be made available for us so we can always go through it. So yeah, thank you very much for your time. If there's any question, please let's ask. If anyone has a question, you can just hit. All right, so I believe we're still digesting the whole thing, which is fine. So we'll be drawing the curtain here for today's class, and we're going to be calling it a day. So I'll try to make sure this is made available as soon as possible. All right. Hopefully this night, so you can go through it before tomorrow's class. Yeah. Okay, thank you very much, and do have a splendid night.